All right, here we go again, Patriots. This is like take 3 or 4. This is ridiculous. I can't get this down. I keep saying the wrong stuff, getting tongue-tied. So let's try this again. So what this video is going to be about is our least square lines and the vocabulary for those least square lines. This equation is the equation of that line. It's called y hat equals a plus bx. It's a lot like y equals mx plus b. Y hat, though, it's because it's a little rooftop, is of my predicted value of y. Okay, that's what the y hat means. So when we make these best linear equations representing our data point, we are going to know my least square criterion is the right one when the sum of the squares of the vertical distance from my data points x and y to the line are as small as possible. What that means, if I give you a scatter plot, here's my scatter plot. You can see what it's doing a wolf population and caribou population. I know this trend line is a good trend line. When I take these distances, the vertical distances from each point to the line, I square them and I add them together, and that sum is as small as possible. That's my trend line. Okay? Now, we're not actually going to do that part. What we can do, and how we figure this out, how we're going to figure out y hat equals a plus bx, is by finding all of these values. Sigma x, sigma y, sigma x squared, sigma y squared, sigma xy, the mean of x, the mean of y. To find our b value, the slope of this line, we can plug it into this formula. To find our y-intercept, we're going to plug it into this formula. And just as a reminder, these two things are different. You can read up in what it says. I got you. You know we're not going to actually do this by hand. We're going to use our calculator, okay? But this is how it is done by hand. Here's how we find our slope. Here's how we find our intercept. But we are going to use our calculators. So, because what does this equation tell us? Y equals a plus bx. Let me write that down real quick. Y equals a plus bx. We already said that a is my intercept. Y hat, there we go. The intercept. What this means is when when my response 0, my y value is 0, what is the x value? What is my explanatory value? When there are no response variables, how many explanatory variables do I have? B is the change in the response variables. What does y change for every change of one explanatory variable? It's the slope. But we're looking at it when the explanatory variable changes by 1. Okay, that's called marginal change. The marginal change is the change in y for every one change in x. I would just like to remind you, this is kind of important. The average x and the average y values are always going to be on my least square lines. Okay? And as you can see, here's going to be my point, some point I generated so I can draw it. We're not going to draw these by hand. We're going to use Google Sheets. So this is just kind of in there to show you what I'm talking about. So if I want to predict y hat values, because that's why we have a trend line. We have trend lines so we can predict values. Well, there's two ways we can predict values. We can predict values between my x values. That's called interpolation. And we can predict values predict y values that are outside of my x values. It's called extrapolation. However, extrapolation can sometimes cause us to have unrealistic forecasts, or our work can go sideways. Because if we're looking at the height of human males, and I collect the data for 5 to 10-year-olds, and then I use that, I create my trend line, and then I use my trend line to predict the height of a 40-year-old. That's not good, because at some point we stop growing. And even though there's a positive correlation between age and height, because the older I get, normally the taller I am, especially between the ages of 5 and 10, at some point people stop growing. So using extrapolation, be aware, sometimes extrapolation can go wrong. One of the things we're going to talk about today is called coefficient of determination. So we've already talked about an R value. An R value is my correlation coefficient, and it tells us how tight our data is, how tight it is to that trend line. Like, and we either want it to be positive, as close to +1 or -1 as we can get. Does it have a positive correlation or a negative correlation? And the closer we are to 1 and -1, the better. Okay, so 0.9, that's a pretty good correlation. If I square it, that is my coefficient of determination. I get 0.81. What this tells us is that the change in the y value is about 81% of the is related to the change in the x variable. Okay, so if we square r, we get r squared. That's the percent that I can say y changes because of x. Well, I know what you're saying. Well, what about the other 19%? Well, that other 19% is either a lurking variable or random chance or noise or something else. Okay, so if we square r, we get r squared, which tells us how much does y change because of x alone. The remainder is my lurking variables or noise or random happenstance. And then this is a recap of what I just said. So when we find r using our calculator will give us our r value. If we square it, that is my coefficient determination. The coefficient determination tells us how much of the change in y can be directly attributed to the change in x. And if we do 1 minus r squared, that is my lurking variable change. Okay? So I have mentioned several times calculator, calculator, calculator. I do have calculators for classroom use, but you've got to get your own. I know that people have checked them out from the bookstore. Please do go to the library, not the library, your local retailer, pick one up, get one on Amazon. eBay sells used frequently. Get yourself one. Most of us want to go to college. You're going to need your own calculator then anyway. So if you got questions for me, Patriots, talk to me in class, and we are going to do some work with this tomorrow. Peace, and I'll see you when I see you.